by Red Hat. So I've been doing software-defined storage for, gosh, 11 years already. So I'm just, you see, the gray hair, that's what it gives me. So I'm just here to tell you about something we moved the Data Foundation, OpenShift Data Foundation team and the Ceph team over to IBM. So what you know as the Red Hat product called Red Hat OpenShift Data Foundation, we now have an offering on the IBM side, and one of the components of that product is basically Data Foundation, but we also have other features in what we call IBM Fusion. So it's just a brief introduction. I don't want to kill you with like too many sales slides, so I try to remain on the technical side so that you get an idea of what is in IBM Fusion. And obviously, if you have any questions around Data Foundation and Ceph and whatever, just like we'll have some time for questions at the end. I try to give, I think I have like 22 real slides, so that should leave time for questions. I'm based out of Vegas, so North America. I'm 2 hours ahead right now, but I'm still alive. So we kept the same principle for Fusion that what we had when, you know, Data Foundation, first it was called OpenShift Container Storage. If those of you remember that times, who remembers OpenShift Container Storage? I see your hand down there too, whoa. If you hadn't raised your hand, I would have had questions. So we kept the same concept. It's all operator-based, and we'll see there's a slide about the list of the different operators that we have in the product so that we can deploy the features in Red Hat OpenShift. So the storage, the Fusion offering comes in two flavors. One is a software only, this guy right here, and this one doesn't want to work. Okay. Oh, I'm pressing the wrong button, that's why. Right here, so Fusion software. So it's just a software-only offering, and you deploy that on top of OpenShift. So you deploy your operators, and then you select the modules that you want to activate from the catalog, okay? But we also have a bundle offering, which is hardware plus software. So we'll cover the list of all the functions in the software, and there is a little portion on the hardware. And what is the hardware for? It's like an idea that you have pre-validated hardware to deploy your OpenShift cluster. We like to call it OpenShift in a box. That's the marketing term that we use and that we have coined. And this was actually before other people started making bundles, I mean, qualified hardware for Red Hat OpenShift. That product has been around for 3 years already. So we have had time to refine it. And I'll give you a brief explanation on one of the slides of some of the new improvements that we did. And there was even an OpenShift admin session about what we're doing with Fusion and hosted control planes. So basically, quicker to deploy. And we support all of these different platforms for the software. So AWS, Azure, Google Cloud, IBM Cloud, VMware, when OpenShift is on VMware, OpenShift is on Z, OpenShift is on P, is on bare metal, or running using OpenShift virtualization virtual machines. So the HCI system is basically the idea of a plug and play, okay? So a rack arrives on site, and we can have multi-rack systems. And as we grow, we keep adding the capability of extending the actual OpenShift cluster even bigger. So we do support, we'll see Metro DR, we support regional DR with the rack. And the idea is that it's easier for you to deploy. Our top record is less than a day to actually deploy an entire rack, single rack, not multi-rack, with OpenShift on top and our Fusion software on top. So the idea is that we have a limited number of ports that are in the rack to get into the customer, basically, network. And all of the rest of the network is actually using high-speed switches inside the rack, top of the rack switch. So we have like dedicated ports to get into the customer network, and we have our own ports where we do all the rest, including the storage. So pretty easy. So we do ask when people want to use that solution, we have like a very nice like to-do list, right? That we have to send to the customer. They have to specify what is going to be their power, how they're going to attach the power, what kind of networks they're going to have, the type of SFPs they're going to use. Are you going to use copper? So we have to ask all these questions so that when we manufacture the box arrives exactly tailored for the customer environment. That's why we can spin up that OpenShift cluster in an easy way. So during the install process, we choose the OpenShift version that we want to install. So appears a list, basically it's a drop-down box with all the Q8 version, OpenShift version that we've done. You choose, and actually our install process has all of the ISOs that are needed to deploy the OpenShift cluster. So we have different type of nodes inside the rack. So obviously we have compute nodes. Compute nodes are going to be used to do what we call the control plane nodes now these days. Worker nodes, high-speed switches, management switch, and we also have something else that we call AFM nodes. So AFM are specific nodes that have basically CPU and RAM. They're diskless except the boot drive, so that we can add specific software so that we can enable advanced functions such as caching, for example, for object stores, or caching for NFS mounts or CIFS mounts. So we basically add the capability of what you can do from an application perspective. We also have GPU nodes. So you can choose different types of GPUs. Just one note for the people that really want H100. The supply chain is pretty tense, and yes, we have it on the catalog, but right now the problem is to get our hands on H100, but we do have available for supply L40S if you want GPU nodes. So depending on what you want to do from the GPU side, we may have a solution, and we have some supply when the customer wants to order. So the compute nodes, we have two types. We have like 32 cores and 64 cores. And the compute nodes, the latest generation, can expand up to 2 terabytes of RAM in a compute node. So it's sized enough so that you can do pretty demanding applications, especially in the AI field, if you want to run your OpenShift cluster. So just a brief example of what we can do. So the minimum that we do is going to be a 6-node cluster. Why? Because we need 3 control plane nodes. And what we're going to do is that we're going to have 3 worker/infra nodes, and you can decide how you're going to do the deployment. That will have the physical hard drives. So basically, it's all NVMe based, TLC based NVMe. That's going to be our base, and that's why it's the minimum. We're going to have, in the next generation of hardware that is coming out and the new versions of the software, we're going to be able to go down to 3 nodes. Okay? For now, it's 6. Soon it will be 3 only. And then you can expand, and you choose how you want to expand. If you need compute only, well, you order compute only nodes with no disk drives. If you need nodes for storage, you order the nodes that have the NVMe drives in it. If you want the advanced functions, the AFM nodes, you order AFM nodes. You want GPU only, you ask for GPU only. So the idea is that we can go up to a 3-rack cluster, and that's going to give us like a little over 2 petabytes of usable capacity for the storage. So with 2 petabytes, you can start doing a few things. Most of you are probably aware, and at least that's what I see from the conversations I have with the customer. Many OpenShift clusters don't have that much usable capacity. Why? We're still at the beginning of the way that people modernize applications. We have a big uptick and a big demand around OpenShift virtualization that tends to be way more demanding in terms of capacity. But from a pure container perspective, we're still limited. We very often see clusters that have, I would say, somewhere between 50 and 250 terabytes usable. It's kind of generic. We have even smaller, but that's basically like kind of the high end. If you're somewhere between 50 and 250 terabyte usable, you're like in the top scale. So we do support a regular OpenShift deployment. So basically bare metal deployment. You have a single OpenShift cluster and that's it, you're up and running. We also do support hosted control planes. So with our control plane nodes, we're going to deploy the HCP control plane, and then using OpenShift virtualization, we're going to create hosted clusters. So we use in the bare metal hosted control plane what we call ODF provider mode, so that we can have the equivalent of OpenShift Data Foundation, except that is through Fusion, right? So that all of the hosted cluster can actually consume storage in that bare metal control plane. So your hosted clusters become client of a bare metal storage cluster. That's the way we do it. So in the software, so we have what we call the Fusion 5. So we have most of the stuff that you used to have in Data Foundation, plus a few extra features. So we're going to do persistence. So you're going to have all your PVCs, you're going to have RWX, RWO, object storage, whatever you need to do. We're going to have resilience. So we're going to replicate the data. We're going to support snapshots and clones. We're going to support multi-cluster backup and restore. There's a slide about that. We're going to support Metro DR. We're going to support regional DR. For security, at rest and in-flight encryption, we do support external KMS also, so that if your keys are in an external KMS, we can do that. RBAC, multi-factor authentication, cyber resilience. We do support all of the cool new features that we have. When you do a backup, we send it to kind of a vault where we do the analysis and the threat detection on the backup, so that we can make sure that no one touches a backup that has been validated as threat-free. That's also part of our offering. We do support mobility. So backup and restore is also included in mobility. Why? Because our backup and restore tool that behaves like a traditional backup tool. Remember where you have a catalog, you do a backup, and then in the catalog, you see the list of all the backups that you've done, whatever the server where the backup was done. So we can actually restore an app. It was backed up in one OpenShift cluster, whether it's a hosted cluster or not a hosted cluster. And we can actually restore that app, so all the CRs and all the PVCs in a different OpenShift cluster using that single control plane where we control the backup and restore. So very similar to traditional backup, but we do that for OpenShift. So migration toolkit for virtualization, so that we can allow you to move VMs into your OpenShift cluster. Migration toolkit for containers, to move your containers from one source to another one. And multi-cloud gateway to do S3. And we have a few other tools, such as automatic discovery and automatic tagging of the data. So we have one of our operators that does data cataloging. So you point the software to a place where you have files and objects. We analyze the content of that target, and we categorize, and we can automatically say, well, if you find like the PNG file, I want to add to that asset automatically a tag, metadata that says this is an image. And after that, you can actually query the database so that you can identify the type of data that would be a threat. You can use it for governance, what data can move out, what data must stay on-prem, for example. So you can do all that through the querying of the catalog that we build through data cataloging. So it's all operator-based. So we have a day one install, whether you do Fusion software or Fusion HCI, no difference. So we have all of the monitoring and the availability that you have in OpenShift. So we do the same. We can deploy multi-AZ, depending on basically what you want to deploy and where you want to deploy. We manage the upgrades through the operators. And this is the complete list of our operators. So we have what we call a Fusion base operator. It's like the meta operator from which you can install other operators. We have a data foundation operator, which itself is a meta operator that deploys RHUG, multi-cloud gateway, and Raman DR. So Raman DR is the operator that we use to control disaster recovery, whether it's metro or regional. Now, one note, just like OpenShift Data Foundation, Raman DR requires the use of ACM to actually drive the failover and the failback of the applications that you protect through DR technology. We have the Fusion Backup Operator. We have the Fusion Global Data Platform Operator. So that's basically a scale containerized version where we can either do a deployment inside OpenShift, so container native storage, but we can also do a remote mount of a scale cluster for the people that have, for HPC, for example, scale clusters. And we have the Fusion Cataloging Operator. When it was sold standalone in the past, it was called the IBM Spectrum Discover. So it's basically a containerized version of IBM Spectrum Discover. So it's all managed through the OpenShift console, and we'll also have a Fusion console where you can drive specific functions. So when you go into the top of the menu bar in OpenShift, there are the 9 squares where you can click and see the other console plugins that you have. You click in there, there's a page that says Fusion UI. So we can do CNS, and we can do CNS on any of the platforms we have, right? So whether it's IBM P for power, Z for the mainframe, OpenShift on x86, anything you want, bare metal or virtualized, we can actually deploy what we call CNS, or you will hear the term internal mode. We can also do CNS in Z and P. So the only thing that's going to be different is going to be the type of physical storage we use. What I always say is that Fusion creates an abstraction layer between OpenShift and the physical storage. So whether you're in AWS, you will see the same storage classes. If you're on bare metal, you will see the same storage classes. But what is underneath physically will be different. We do have what we call a CRS, or external mode deployment. So we're basically connect our OpenShift cluster to either an external Ceph cluster or an external scale cluster. And you can actually do both at the same time. So you can have one OpenShift cluster with one workload that's going to require like HPC style like throughput and bandwidth. Customers will very likely have a scale cluster. But at the same time, they also want to do, for example, S3A, because they have a lake house and they need access to S3 objects in S3 buckets, because some time ago they replaced HDFS with object storage through S3A. You can mix that in the same OpenShift cluster. So the features, that's kind of in extenso what we do, the storage abstraction, the different storage types that we support, block, file, and object. We do support all native distributed protocol. Yes, we can do NFS, but as most of you know, NFS is not the most advanced protocol for accessing data. So all of our protocols that we use are actually native protocols that are what I call client to cluster, not client to server. So when you're actually making IOs, you're not talking to a single guy, you're talking to a whole bunch of guys, so that you can actually parallelize actually the throughput, whether it's IOPS for small IOs or larger blocks. Anywhere we're going to split the data into different small pieces so that you can actually leverage talking to multiple people at the same time. So we do support HA and DR. So we're very aligned with what we do with OpenShift. The difference is that we approach it from a storage data perspective. When you think about OpenShift DR, we're raising ourselves at the level of the application. Right? We try to bring intelligence into the application level so that you can deploy an app away so that you can do DR or high availability. We basically do the same, but from the storage, the persistent data perspective. And we do support backup and restore. So we have had for over a year now what we call the hub and spoke model. So we have one server that has the catalog, and we drive the backups and the restore across multiple OpenShift clusters. So the OpenShift cluster where we drive the backups and the restore are called the spokes, and the place where we have the catalog, where you create the policies and define the targets where you want to send the backup data, are actually on the server on the hub. So RWO, with RWO, we do support block mode and file system mode. Block mode is very important for OpenShift virtualization because we gain better performance by not putting like a dummy file system between the VM and the actual storage. That's what we do with OpenShift Data Foundation. It's the same with Fusion Data Foundation. We also do support file system mode with a scale, so no block mode. So because scale is RWS capable, like the next bullet shows, you can actually use for OpenShift VM migration, hot migration, you can use either scale RWX or Data Foundation RWX block mode. You can do both, right? So we do support all of the objects. So we are Cozy ready. So Cozy is still being refined. We have had the code for Cozy, but we are still officially pushing what we call OBs, object buckets, and OBCs, object bucket claims. And basically Cozy is like the next generation of OBs and OBCs. OBs and OBCs were introduced by Red Hat through the acquisition of the Nubat team when the upstream project got acquired. And Cozy will be the next thing, and we are ready for it. So backup and restore. So we're gonna be able to send the backup data to an S3 endpoint. And we have a whole bunch of different S3 endpoints that we support. So we have obviously AWS, we have Azure Blob, we have Ceph, we have Storage Protect, which is another IBM product. Basically, we're using very simple S3 semantics to send the data to the S3 endpoint. So anything that is S3 compatible will work as an S3 target. So we have the hub, and that's where we basically manage all of, it's already dead. So that's the one where all of the backups are actually being scheduled and pushed down to the spokes so that you do the backup. And you can have a whole bunch of spokes where we're gonna do the backup. So protecting an application is pretty simple. You need to have a backup location, right? Where do you send the data? You create a policy, say how often you want to backup, what is going to be the retention of the backup data, and then you assign that policy that also points to the target and say, I want to back up that OpenShift namespace with that policy. And that's it, you're done. So it's a three-step process. So we also do support what we call backup recipes. So when you have an application that is complex, where you have a database, you know that before you can get an application consistent backup, you're going to need to flush all of the memory, basically, the transaction logs, so that they're all on disk. So we have this backup recipe concept where you can actually say, before I do a backup, I want to freeze the app, then take a snapshot, then throw the app so that the app restarts. So we have like default ones, and we made them open source. The first step that we did to create recipes was to support the cloud packs that you've probably heard about at the IBM Cloud Pack for data, Cloud Pack for integration, Cloud Pack for business automation, and there's probably some I forget. So you can also write your own. It's pretty simple. It's a YAML. You say, this is how I want to do it. These are my PVCs. These are the steps that I want to do before I do the backup. And this is what, and you do the same for the restore. So remember the advanced feature with the AFM nodes that I was telling you about. So one of them is remote object store acceleration. So what we do is that we use basically the global data platform to intercept the calls to an S3 endpoint. And every time you're trying to do a get on an object on the S3 endpoint, we bring the data back, we store it on the NVMe drives. So the next time you come and ask for the same object, guess what? We're going to serve the request directly from the NVMe drives. So it can be, and what we have measured is 10 to 15 time acceleration. Now, obviously, if you have an object store that is already all on NVMe, well, the acceleration, it will only be the proximity with the app that is asking for, for the data. So the acceleration will not be as great, but it will still be a little bit accelerated because now you don't get out of the OpenShift cluster, you serve the data from inside the OpenShift cluster. We have done the same work for any NFS mount. So you can actually place Fusion between your app and an NFS mount. And the same, when you're asking data from the NFS mount, well, we serve it from the NVMe drives. And data cataloging, so the old IBM Spectrum Discover, we're going to scan the data sources so that you can get better knowledge and you can make decisions, because around the catalog that you can now query, where we have analyzed the data, tagged the data, you can actually define automation with whatever tool you want so that you can make decision on what you want to do with the actual data that sits somewhere. And that data could be on an FS mount, could be in an object store, could be in a scale cluster. We're going to add support for CephFS, so a Ceph file system. It's coming in 2.9, which is at the end of this year. So you gain better control about how you actually manage the data and what you want to do with the data. HADR, so we do support high availability, obviously, just like we do with OpenShift. 3 availability zones. That can be in AWS, that can be 3 racks when you're on-prem. You can do whatever you want. We also do support for Fusion 2 AZ deployment. So we need an arbitrary location to place a specific piece of software so that we can manage the maps of our storage clusters. So you can do 2 or 3. So we do support regional DR. That's an asynchronous replication between our storage layer. And you basically have 2 separate OpenShift clusters, each with their own storage cluster, and we asynchronously replicate the data between the 2 OpenShift clusters, which is basically 2 storage clusters. We also have Metro DR when you have a latency low enough so that we can do synchronous replication between the 2 data centers. We can do that. Okay? So you can really grade the way you want to deploy based on what you're trying to achieve in terms of availability and disaster recovery. I try to stay in time. Any questions? All right, thank you very much.
Thank you, lots of information.